Good afternoon, everybody. So my name is Alex, and to continue my previous presentation, I'm going to talk more about interoperability in the electronic health record system. So I'm sure all of you recall that last time I talked about the background. I gave you motivation of why we should care about interoperability, and I gave you some overview, a brief overview of archetypes and the Galen terminology service. Today, I'm going to skip those topics and go directly or present to you a different problem, a slightly modified problem statement from last time. I'm going to talk about two design methodologies. The first one is called single-level methodology. The second one is called interoperable knowledge methodology. And I'm going to present to you some future works. So this is the long version of the abstract. And the two key points that you should notice out of this is that the electronic health record system is a system of heterogeneous information systems. So there can be a lot of differences between different implementations. And the second thing you should notice is that design methodology plays a key factor in determining whether a group of systems is interoperable or not. So this is the revised problem statement for this presentation. I'm going to evaluate existing system design methodologies that provides knowledge level interoperability among heterogeneous systems. And by knowledge level interoperability, I mean the standardization of domain knowledge concepts. So how is interoperability achieved? Well, the obvious route to take is standardize everything. If all the heterogeneous systems conform to the same model, then interoperability is not an issue. The second thing you could do is through mediation, and Dominic talked about this in one of his lectures. You have this mediator interface between heterogeneous system that translates messages to and from systems so that they're in an understandable format. So I'm going to talk about first the single-level design model. This is the traditional design method that we're all familiar with. The software developers elicits domain concepts from the experts. Then the software developers hard code these concepts into the software and database models. So you take these requirements, you take these concepts that are specific to the domain, and you as a software developer encode this in an ER diagram or object diagram or etc. And again, this is what we're most familiar with, and everyone uses this currently. Well, now there's a couple problems with that, especially in the health domain. There are a large number of domain concepts in health. Large models are difficult to standardize. It's easier to agree on small units versus something that's huge. And of course, it's really unrealistic to expect vendors and users to invest all their time and energy to standardize between such a large model, like a model with 10,000 tables or something like that. Okay, so standardization is not an option. What about mediation? Because there's no standardization, all the vendors are free to implement or to express domain concepts in whatever way they wish to express them in. And this can lead to an explosion of interfacing modules. Another problem is that health domain, or the concepts in health domain, are very volatile. That means the model can never be complete. Just because you spent 1 year of your development time creating this nice ER diagram doesn't mean that it's going to be valid tomorrow. And what does that mean? That means that data that conforms to your model today may be out of date tomorrow. And even if you're able to achieve initial interoperability, tomorrow it might not be interoperable. So this is the general picture of the traditional design method. You have your domain specialist here, which has this ad hoc discussion going on with the software developer. And the software developer after he gets all the domain concepts, encodes this into a ER diagram there into database schema, which gets implemented in a DBMS, for example, Oracle or DB2. So the thing to notice here is it's pretty big, but the information or the concepts encoded in there are very volatile. And that's a bad thing. So obviously, we need an alternate approach. How do we solve this problem? And the interoperable knowledge design method proposes that we do these two things. First, we encode all non-volatile domain concepts into a small reference model, a relatively small reference model. This reference model is owned, created, and maintained by software developers only. Then the volatile domain concepts are captured in something called knowledge models. These models are owned and created and maintained by the domain experts and stakeholders. So the software developer has nothing to do with this. So here's our diagram again. What we want to do is make that small and volatile. Get rid of this and have these guys, the domain specialists who knows the concepts best, manage the more volatile concepts. So what is the consequence or benefits of this using this method? Well, obviously the domain experts are empowered to define and maintain all these volatile domain concepts. Me or the developers are no longer burdened with the task of modeling these volatile domain concepts. Now, one thing to notice here is all data are instances of the non-volatile reference model, right? So going back to this diagram, notice how this now small and non-volatile schema is the schema that is actually implemented in the DBMS. Not this, right? So your database schema will contain something that's small and non-volatile. And continuing on, that means the data is future-proof because your data conforms to a non-volatile schema. And that also means that the system can be deployed without waiting for all the knowledge concepts to be defined. The bottom line is you get empowerment, you get future-proofness, and you can deploy your system quickly. That's very good. So what does this system do for interoperability? Well, a set of heterogeneous system is knowledge level, can achieve knowledge level interoperability if the reference model agrees and if all the domain concepts agrees. That's basically what it says. So is that easy or not? Let's see. Small reference models, which are non-volatile, can easily be standardized. If I have a table of, if I have a schema of 20 tables, which never changes, it's not too hard to have an agreement among different vendors on that schema. The domain experts and stakeholders are now responsible for maintaining and standardizing volatile concepts. This is an iterative process. They don't have to do it all at once. They can model blood pressure today and take care of eye examination tomorrow. So it is much easier than before. You don't have to do it all at once. So I'm going to talk about, I introduced two main terms in this design methodology. One of them is reference model. The other one is knowledge model. So I'm going to talk about reference model and what it is. So this is a definition of a reference model. It is a partial software architecture covering only aspects relevant to the domain. So this model must be applicable to all who use this domain and must be valid forever. It should not ever change. And Beal, in this document, gave several design principles of how you would design such a reference model. So this is a sample reference model for representing demographic information of a party. So you have your party there, which has an identity. and then have some contacts, and each contact has some address. So as you can see, in general, this reference model is very general. It's not very specific. It can represent all kinds of data. So what will a specific instance of the reference model look like? So if I want to model a walk-in patient for a clinic, I would name the party is walk-in patient. The identity will have the identity of the party. I will call it a client name, and the purpose of that identity is its legal name. And I'll have the title, I'll have the family name, and I'll have the given name. So that's one instance of a reference model. And this is what we will call a template. So now we know what a reference model is. We move on to what knowledge model is. So the reference models give us the specification of valid information. What is valid and what is not valid. As you can see before, with the walk-in patient example, that is a valid instance of the reference model. However, all valid instances of the reference model, only a small portion have meanings in the domain they're interested in, for example, health. And knowledge model is the thing that defines what instances of the reference model are meaningful. So since I have an analogy here, and since I'm not very artistic, I asked my brother to draw this. So the analogy is, imagine Lego pieces. So the reference model is like the Lego specification. You can put a block on top of a block if the bottom of this block goes on the top of this block. So imagine that as your reference model. It's engineering specification of Lego pieces. However, there are infinite number of ways I can put these blocks together. I can make something like that, but what doesn't really is valid, but it doesn't really mean anything. Archetypes, which I'm going to talk about later, are basically domain knowledge models that shows you ways of meaningfully putting pieces together. So, for example, something like that. So, how do we describe these knowledge models? How do we describe these blueprints that shows what is meaningful and what is not meaningful? We can use templates. For example, the walk-in patient template before specified that a patient identity has to have a first name, last name, and a title. However, it's too restrictive. So, for example, the walk-in patient template specified that the walk-in patient only has one identity. And that identity is called a legal identity. What if I want to model a walk-in patient with more than one identity? I want it to have multiple identities, a way of identifying that patient. I couldn't express that with a template because I have to explicitly state the multiplicity. So what we want to do is express knowledge models in terms of constraints on the reference model. I'll show you what I mean. So here, this is the same walk-in patient model that I depicted to you before. However, it is constraint-based. For example, here, the party identity, I can have 0 to n number of government-issued IDs. And the purpose of it is alternative identification. So that is constraint-based. I can either have 0 or I can have n. Another example is here. The number on an ID card is a range. And the range is integer with minimum of 8 digits and maximum 16 digits. So that's what I mean by constraint-based. I don't say that, for example, what is not constraint-based is if I have one instance here, right, versus range. So the constraint-based knowledge model is termed archetype. And what does that do for us? Archetypes allows inbuilt variability because it is constraint-based. And that means that more than one instance can conform to one archetype. You can also specialize archetypes. So you can take an existing archetype and put more constraints on it. And why is this good? It's good because it reduces the total number of archetypes required to model a large domain, such as health. And BL defined the archetype language as the archetype model. And I'll show you an archetype model example. So basically, it's reiterating the same thing. All the stuff, all the data values are mapped into ranges. So for example, here, this relation here is mapped into a range of values. And another example here is, I didn't show before, is strings. A constraint for a string could be a regular expression, right? So now that you know what a reference model and knowledge model is, how do you come up with these models in health? Well, it might not be as easy as you think. BL came up with the reference model for health and the knowledge model for health through an exhaustive process of ontological analysis. And this analysis yielded a 5-level ontology. And this is the 5-level ontology that he came up with. I won't go too much into detail of this. And as you can see, this is a reference model resulting from this 5-level ontology. And by no means is this trivial or simple. So to further convey my point, I'm going to show you, oh, it doesn't open. Well, it's supposed to show you an archetype of a blood pressure archetype and what it's supposed to look like. And the message there is, it is very complex, even for such a simple domain concept. So going back to this design methodology, this is what it looks like if you were to employ the interoperable knowledge design method. Notice that the software developer is now responsible for a small reference object model that is non-volatile, while the volatile concepts are governed way over there by the domain specialists. And here, this is something new. Domain vocabulary is something such as SNOMED, ICD, or Galen. And this is the architecture of a system that is developed using the interoperable knowledge design method. You see here, I have archetypes, which basically constrains data at runtime. But notice how the data are only instances of the reference model and not instances of these archetypes. And the thing to notice here is they're developed separately. So this is a deployment example of something that uses archetypes or uses the interoperable knowledge design method. Obviously, you need ways to store archetypes into the database. So you have an archetype database here. When you insert data, it's validated against archetypes at runtime. And so there's still the problem of representing the same clinical concepts using different archetypes. And how does that work? So for example, I'm trying to put in electronic health record, put an electronic health record into the system, which conforms to this particular archetype. However, the system that I'm putting it into is only accepts this kind of archetype. So what I need to do is I need to translate the document from the local archetype into something that the system understands. And this layer of, so this layer that is handled by the XSLT processor does the translation. And the same goes for retrieving the documents. So I'm going to give you some thoughts on this design methodology. As you can see, it's crucial to have a good reference model. If the reference model is not good enough, there are some concepts that you cannot express, or if the reference model is actually volatile, then you run into big problems. So what is this domain empowerment? Well, I see that as a shedding of responsibility, which is not necessarily a bad thing, but consider the fact that the software developer is no longer burdened with modeling these volatile domain concepts, but now this hard task is delegated to the domain experts. So here are some ideas for future work. How do we query these data? Okay, so querying data is one thing. And how do you validate data against archetypes? Right? So that's another area for research. Dynamic user interface, displaying data that conforms to different archetypes requires different user interface. So for example, if I'm viewing data that is of type blood pressure that conforms to the archetype blood pressure, it should probably be presented in a different way than data that conforms to the archetype eye examination. So again, archetype mappings, if there are two different concepts but described in different archetypes, how do I perform the transformation there, manually or automatically? So conclusion is this methodology, this new methodology, provides us with these three things: domain empowerment, future-proofness of data, and knowledge level interoperability. And those are recapping just what are the areas of research. And here's the last slide. Any questions?
Is there an example right now of a health information system that's used the archetype concept in a full-blown way, other than
there was a trial done in Australia and Europe, but the trial ended about 2 years ago, I believe. And there are substantial amount of documents, studies, lessons learned type things that resulted from that trial. The name of the project, I believe, was called GEHR, Good Electronic Health Records. And I think the reference is here.
How far did they actually get? Did they get to create, repeat the question, did they create a complete system?
Yes, they managed to create a fully federated. Oh, the question is, how far did the trial get, or was it, how successful was the trial? From reading the related documents, I concluded that the trial was pretty successful. The biggest system had about, I believe, close to 10 different hospitals using this system at the same time, and they were able to interchange health records with each other without too much of a problem. So that was a positive experience in general. And what the initiator of archetypes, Thomas Beale, is trying to do now is trying to convince people at HL7 that archetypes or this design methodology is the way to go. And they're trying to make that a standard for people who wish to, or countries who wish to implement electronic health record systems.
No, thank you very much.
Okay.